Okay, so the next topic with rational expression is how to multiply and divide them. And that's the only objective we've got. So when we talk about multiplication of fractions, multiplying fractions is by far the easiest thing you can do with two fractions. For example, if I had 2 over 3 times 5 over 7. To multiply two fractions together, you multiply the numerators, and you multiply the denominators. That's it. That's it. However, there is one little catch here. These numbers had nothing in common, right? So it just was easy to multiply straight across the top and the bottom. But if I did have a situation where I had numbers in common, for example, if I had 2 over 9 times 3 over 8. Well, I could just go ahead and multiply 6 and then make that 72, and those are big numbers. And so I don't want to do that. So let me write that a little bit better. So if I had 2 over 9 times 3 over 8, because the number 9 is 3 times 3, that means there's a common factor of 3 in the top and bottom that I can divide out. And because the number 8 can be rewritten as 2 times 4, then that means there's a common factor of 2 in the denominator and in the numerator that I can divide out. And so what I'm left with is 1 over 3 times 1 over 4, which is just 1 times 1, which is 1, and 3 times 4, which is 12. So if your denominators and numerators have nothing in common, you just go straight across. But usually the case is that something can be factored and reduced. And so we do the same thing with rational expressions. Completely factor the numerators and denominators, and then multiply the numerators and denominators. So what they're saying here is this. If I want to completely factor 6x squared, I'm going to write that as 2 times 3 times x times x. Notice these, that's a monomial. There's no addition or subtraction in here. So I'm not going to be doing something like 6 times x plus 2 or something crazy. There's no pluses there. I can't make them appear. But anyways, that's the complete factorization of my first numerator. Then I'm going to move to my first denominator. 2 times 5 times x times x times x. All right. So now let's go to the second one. 5 times x is just 5 times x. And then 12 is 2 times 6. Technically, I should probably do 2 times 6, which is 2 times 3. So now everything is completely factored, right? Completely broken down. And so then it says multiply the numerators and multiply the denominators. What that means now is that I can take all of this stuff up here and I can reorder it however I want. So I'm going to reorder this as 2 times 3 times 5, and then I've got x times x times x. So the same things, but just reordered. And then I'm going to do the same thing in the denominator. I'm going to take these things and I'm going to reorder them. So 2 times 2 times 2 times 3 times 5. So notice all I'm doing is I'm going through here and I'm getting my numbers in order, right? Just because I'm an orderly type person when it comes to math. And then my x's. And so now that everything's been multiplied in terms of like rearranged, I can now see the following. 2 divided by 2 is 1. 3 divided by 3 is 1. X divided by x. X divided by x. X divided by x. Ooh, 5 divided by 5. That was exciting. So everything in the numerator divided out, meaning that everything in the numerator is a 1. And 1 times 1 times 1 times 1 is 1. And then in the denominator, all I'm left with is 2 times 2, which is 4. Now, that's what's going on, broken all the way down. Some of you may remember how to do the following. If you don't like what I'm about to do, then you should do it the way I showed you. But some of you realize, or remember that, 5 goes into 10 twice. 6 goes into 12 twice, right? And of course, that's a 1 and that's a 1. And then, let's see, x squared is going to drop that down to just a first power. But guess what? Now I've got x divided by x, which is also just 1. So technically, you've got x squared and x, which is really x to the third, right? And then x to the third down there, so that cancels out. And so that leaves you with 1 times 1, or 1 over 2 times 1 over 2, which is 1/4. So that you have some flexibility when they're like that example. The next one is now like the factoring we've been doing. So let's do this example because it's got some more meat on the bones here. So m minus n squared, that's already factored. I think it's important to note this though. M minus n squared is this, isn't it? Oh, it's doing that. I didn't really factor it. It was already factored, but I want you to see what it really is. M plus n I can't do anything with. M I can't do anything with. But m squared minus m times m. Well, that's this, isn't it? Meaning there's a common factor of m, and when I remove it, I'm left with m minus n. And so that's what I'm doing here. I'm dividing out an m, which leaves me with m minus n. So, is there anything in common now? Well, clearly those divide out, right? So again, all I'm going to do, guys, is I'm going to recopy this so that those that just look at the notes don't see a bunch of stuff scratched out over stuff. But m over m cancels out, and m minus n, I can take one of them out. And I'm left with m minus n in the numerator over m plus n in the denominator. And I'm done. Can't cancel across that addition or subtraction. Let's see, is there another multiply? No. So those are examples for multiplying. The division is the same thing as multiplication. So if you look here, if you are dividing two fractions, what you are going to do is you are going to copy the first fraction. So you are going to take that first fraction and you are going to copy it down. And then you are going to take the division symbol and change it to multiplication. And then you are going to take that second fraction and flip it. So what you do is a process called copy.flip. When you see division, you are going to multiply the first fraction by what's called the reciprocal of the second fraction. So copy dot, flip. So division means copy dot flip. Now, the fancy word for flip is reciprocal. So if you think about a reciprocal, the reciprocal of 2/3 is 3/2. The reciprocal of, we saw earlier, x plus x over 8 would be x plus 8 over x. So reciprocal, let me write this as an example. So the reciprocal, I can't even spell. Why am I getting hung up? Reciprocal of 2/3 is, and the reciprocal of x over 8. Reciprocal, guys, doesn't mean that you switch a sign. So like if I had, let's see. What I mean by that is if I wanted to know the reciprocal of negative x minus 7 over x squared plus 2, it would be negative x squared plus 2 over x minus 7. So reciprocal doesn't mean to make anything sign change, it just means to flip. And that's going to help you on number 1 of the College Math Homework 11. These are to multiply. So the first example that I did in this one, you're going to look towards, why does it keep doing that? You're going to look at that first example I did to help you with these. And also this one, just remember that if you have a whole number, can it be written as over 1? Sweet. And then on these, you're going to have to maybe do some GCF, or like I see some diamond stuff going on there. Here, this is GCF, 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 GCF. Blah. And then the rest of these are divide. And then down here, I've got one more multiply right here. Ooh, challenging. Challenging. You may have to think about that. But as far as the division ones go, what you're going to do is you're going to copy dot flip, and then you are going to multiply. So when I see a problem like 3x to the third, when I see this division, as soon as I see that division, that's what tells me to copy dot flip. That's how I know to do this. Let me write this a little bit better. So as soon as I see this symbol right here, I'm going to copy my first fraction down. So this is just going to become 3x to the third, y to the 7th over 40. You never, ever, ever flip the first fraction, ever, 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 ever. And then I'm going to dot, meaning I'm going to change that division symbol to a dot, which is a multiplication symbol. And then I'm going to take the reciprocal of, which just means to flip, that second fraction. And now I'm back to an example like the first one where I'm just multiplying. And so if you look at this example, the only thing that I see in common is that right there. So I'm going to go ahead and divide that out, right? I can go ahead and divide those out. And so when I divide those out, I'm left with 3 times y to the 7th times y squared over 40 times 4. And all I can do there is realize that I have a total right here of y to the 9th over 160. And that's it. That's all I can do. So just as a side note again, that and that divided out. And that's how you divide rational expressions. So again, let's look here. I see my division symbol. So I'm immediately going to say, okay, I have got to take this expression because I'm dividing, and I'm going to copy dot flip. Not doff, but dot. So this is going to become x plus 2 squared over 10 times 5 over 2x plus 4. And this problem is literally like example 2. I don't want to say literally, that's retarded, but because it's not literally, it's just structurally very similar. Meaning that I'm going to remember this. X plus 2 squared is just this. It's already factored, but I just want to kind of expand it out. That's 2 times 5, and then that's 5, and then notice here, I can factor out a 2. So if I divide out a 2 from here, I don't want to say divide out, if I pull out a 2, factor out a 2, I'm left with x plus 2. And so now I can see all the things that I'm going to be able to cancel, which would be a 5 and an x plus 2. Right? So I can cancel these together, or cancel those out, and I can cancel these out. Which what I'm really saying again is divide by, or divide them out to 1. And so what I would be left with after I did the process of dividing these out, so again, if you want me to kind of prove it, whenever you multiply fractions, all you do is you multiply the tops together. So if you look here, that would become 5 times x plus 2 times x plus 2 over 2 times 2 times 5 times x plus 2, which is going to allow me to divide these out and to divide out one of those. And so I'm going to be left with x plus 2 in the numerator over 4 in the denominator. And that is as far as I can go because I cannot cancel across that addition. All right, I think this is the last one for here. So remember, to divide by a rational expression, multiply by its reciprocal. Literally just flip. So again, this is very similar to what we just did. I've got x plus 3 times x plus 3. Now again, I just do this step to remind me. Not everyone needs to do this step that I'm showing. Actually, I lied. I don't need to do that first. I need to copy, dot, flip first. Because what am I looking at here? Division. So I'm going to copy, dot, flip. And now, after I do that, now I can think about what I'm going to factor or break down. So just to remember, this is x plus 3 times x plus 3 over 5. 25 can be broken into 5 times 5. And in the denominator with 5, in this denominator, 5x plus 15, I can divide those, or factor out, I should say, by 5, leaving me with x plus 3. And so now the numerator has 5 times 5 and x plus 3 and an x plus 3. And the denominator has a 5 and a 5 and an x plus 3. So what I'm able to do, and again, guys, you could have done it here like this. You could have said, but lining it up, I can really see that this is a 1, this is a 1, this is a 1. And so all I'm left with here is x plus 3 over 1, which we would just simply write as x plus 3. And there you go, multiplying and dividing rational expressions.